I'm here in Germany, not far from Cologne, and I'm here to visit the headquarters and testing lab of a very interesting tyre factory. This is Schwalbe headquarters, and I'm here to take a tour, learn a thing or two about how they design, make and then test their mountain bike tyres, and also take a look at their new range of radial tyres, which is an exciting development in mountain bike technology. Did you know that Schwalbe is almost unique in the fact that they specialise in bike tyres? They do some wheelchair tyres, the ones that are the same size as bikes, but it's all about road, gravel, mountain bikes. That's what they specialise in. The company started in 1922 and it's still a family company, same family. And believe it or not, it started exporting small bike parts from Europe to Asia, including lots of parts from the UK. Well, that all switched around in the 70s when cycling was really taking off as a leisure activity, adding an oil crisis here or there in the 70s where there was actually car-free Sundays in Germany and more people were on bikes and they realised that their speciality was tyres. So they dropped everything else and got into developing and making better tyres. A really interesting part of the company's history started in 1981 when a young teacher called Wolfgang Reich decided he wanted to ride his bike around the world, and he wrote to 80 different companies asking for them to recommend products that would be up to the task. Schwalbe took that as an opportunity because they're already designing a robust tyre. As you can see, there it is. It's the very first marathon. And that's actually Wolfgang's bike that he rode 73,000 kilometers on, 1981 till 85. He did it with a lady called Gudrun Braht. And actually, yeah, he did it with the help of Schwalbe, testing the tyres, but also sending back samples, so dropping them off at German embassies en route, and even picking up new tyres there as well. But check out this document. It shows where he was, Bremen, or where they were, say, Sao Paulo, Tijuana, Sydney. And he's keeping notes of the conditions, the type of roads and trails they're riding on, and actually how the tyre's performing. You can see these lines, that's where the tyre swaps from rear to front. So incredibly detailed document, and that was the start of what is still Schwalbe's most popular tyre, the Marathon. Fast forward to the 90s and their very first cross-country mountain bike tyre, the Black Shark. That is a very brief history of the company. Now let's get into how they make the tyres. Schwalbe is a German company, but they have sales locations all around the world. They've been partnered with a company in South Korea since 1972. And the tyres are actually made out in Vietnam and Indonesia, where all the raw materials are coming from. So did you know that rubber, the main raw material for tyres, is actually harvested from rubber trees? So you see here as well in Indonesia, the rubber is being harvested by smallholders mainly, and it's less than 150 kilometres from the factory where the tyres are actually getting made. They're also working with a foundation called Fair Rubber to make sure those smallholders are getting paid fair prices and protecting orangutans, because it's done in a jungle culture. Biodiverse, it's not just a monoculture. So this is, you can see where actually they're getting the rubber from the trees. That natural rubber is collected once a week and the farmers are paid. Then it's off to the first process, which is crushing and washing it. You end up with this, a lump of natural rubber, and then the sort of chemistry starts. You've got synthetic rubber that is put in with that, and that can change the characteristics straight away of rolling resistance and grip, other fillers and additives. It's all put together. You end up with this. That is the tyre compound. So that is designed basically for the riding characteristics you want. You then get into the sort of components of a tyre. That is extruded for the tyre tread. So you've got these ribbons that will become the tyre tread. You've got the tyre carcass, or the casing. So that is where this nylon fabric comes together with rubber as well. And then it goes over to one of these building drums. So the carcass is laid on first, the tread on top, you have the beads down the side, it is cut, it's folded over, and you end up with this. That is a Magic Mary. Well, it doesn't look like one yet, does it? It's not been vulcanized yet. This Magic Mary is called a green tyre, so basically construction is finished, but then it goes into one of these moulds, which is basically a negative of the tyre tread, so they need one of these for every single tyre. size. If I can read backwards, this is a Magic Mary 29 2.4. So tyre goes in there, this airbag goes inside, so it's pressurised, and then the other side of that mould obviously comes down, goes in, gets heated up to 170 degrees, something like that, for 6 minutes, and that extrudes all these rubber treads you can see here, and that is why you end up with those furry bits on your tyre, as the rubber sort of gets pushed out into those negative holes. Once they're made in Asia, they are shipped to this massive warehouse, which is next door to the HQ, which can house up to 4 million tyres. I think I left a Magic Mary somewhere. Where'd it go? But before a tyre is made, it needs to be designed. All right, so we've seen how a tyre is constructed. We've now come into a very nice workshop, I've got to say, with a very nice coffee machine. I talked to Carl, the product manager, about actually designing tyres. How do you go about it? Obviously, you've got the coloured bands on the tyres for the compounds of the tyres. You know, you've got rolling resistance, compound, grip, everything has to add up to make a good tyre. I mean, what does make a good mountain bike tyre?
Well, there are a lot of metrics that you have to consider, but when we simply talk about grip, I like to describe the 3 phases of how we can generate grip. So the first one is compound. You just mentioned the purple line. That stands for ultra soft compound. The name already gives it away. It's a soft compound. So the first metric that's important is hardness. The hardness of the compound describes how well it can conform to the ground. But I have to give away that this is not the most important metric. Probably the hysteresis or the rebound resilience of the rubber is much more important. So getting back to the 2 phases of grip, I mean, phase 2 is the tread pattern, which we've talked about before, and phase 3 is the casing. Okay. So I could have the best compound ever. If I don't manage to get it to the ground through a supple casing, then I will not have a grippy tire, right? I think it's easy to understand that it's very crucial to maximize the utilization of this tiny little contact patch that we have. So with radial, it's not only the point of increasing the contact patch, but also having a more active tire. Think about the tire articulating to the ground better. So let's say with a standard tire, whenever you hit right over a root in an off-camber section, that's a sketchy moment, right? Mm-hmm. Because what happens is that when the tire rolls over the root, it just lifts off, and for a brief moment, your contact patch, which is already small, right, is reduced to the surface of the root or rock or whatever you're riding over. And the cool thing about radial is that due to its structure, it's not only having a larger contact patch, we're talking about 30% at the same pressure, but also providing contact patch before and after any object you're riding over. So like hitting roots and so on becomes much easier of a task.
How do you go about it? Obviously, you've got current tyres that you maybe want to improve, but you're talking to the pro athletes as well. I mean, where do you start with these tyres?
Well, that really depends on the tire project. Let's have a look at the Techie Chain first. So Techie Chain was a dedicated development that we started with Amaury. It's basically a tire that's completely suited to his feedback, his wishes when it comes to ride characteristics. I mean, obviously he's had good success on the Magic Mary, but especially when it came to corner hold and agility and dynamics of the tire, he had some special wishes. So when we started this project, basically it was based on Amaury cutting down a big Betty according to his needs, because in some circumstances the Magic Mary felt too squirmy for him. Like if you've seen him ride, he's obviously a mental rider, but he just leans his bike over so far that he needs this corner hold that was, depending on the track conditions, he was missing on the Magic Mary. So that was the first starting point. We took the general structure of the Big Betty, the spacing, knob design and so on, and just played with the volume of the shoulder knobs. We quickly noticed that we maybe overdid it a bit with the aggressiveness of the tread pattern. So we went back to the drawing board and played again with the shoulder knob volume, reduced it a bit, made it a bit more flexy, still stiffer than a Magic Mary. And this is basically how the current Techie Chain came up. Pretty open center to shoulder section for the corner hold and like good precision, good feeding. Then we have a lot of braking edges. When you're a racer, you obviously want to brake as late as possible into the turn.
Talking about a lot of this technology from downhill racing, but obviously we're talking e-bikes on this channel. I've got this shredder in my hands, which is a gnarly looking tyre. It sounds like this same tech makes sense e-bikes, you know, across the board for tyres, where you're not really thinking about e-bike specific tyres, thinking about what you're using these tyres for?
True story. Although it worked well in downhill racing, we first considered it only for e-mountain bikes. So the first test we did was 2022 with OEMs in Riva, and that's like a steep climb with some cobblestones.
Now I've slipped past the security guards and entered the top secret Schwalbe lab to see how the finished rubber is smashed, skidded and slashed by a team of robots before we get to try them out. So that's how everything comes together to design a tyre. And don't forget, there's those three things that determine the grip. There's the compound, so there's the friction of the tyre. Then there's the deflection of the tread, that's the mechanical grip. And that casing construction all comes together. And that can be tested obviously out in the wild, in the dirt, but it's also tested here in the Schwalbe lab with these high-tech machines to test all the things, the rolling resistance and the durability of these tyres. So this machine is measuring the rolling resistance of a tyre. It's basically an electric motor spinning there. So it's spinning this wheel, and how much power that electric motor is using is going to tell you how much rolling resistance is through that tyre. So it's super important for all riders, from road tyres up to e-mountain bike tyres. Because you're always looking for a compromise. You want a tyre that is durable, that has got good grip, but is also quite fast rolling as well. So you're spinning along at a good rate and you're not using too much of your e-bike battery. And it's down to the whole construction. So this at the moment is an Albert Gravity soft compound tyre, but actually it's not just the rubber compound, it is the construction as well that determines how fast or slow a tyre is. So we have the roller over there, we have the stabber, we guess what that does. And this doesn't have an official name, don't think, but I'm calling this the laser guided tyre slammer. So this is obviously slamming that metal plate into the tyre, and it is going to test it to destruction. Again, this is an Albert Gravity tyre in there, so it's taken some massive slams so far. Now heading over to the pumper, which is going to test out the bead material and construction. Obviously super important if we're talking about tubeless tyres, how easy they are to mount, but also how sturdy they are on the rim. So this is a Magic Mary, and it's going to start at 2.6 bar and go up to around 7 bar of pressure. So that Magic Mary Super Gravity got up to almost 9 bar. Obviously it's water inside, you may have noticed. It's just safer than using air. But not recommended. I think 2.6 bar is maximum, so don't try that at home. Now we're going over to a digital microscope. Right, so this is that poor Magic Mary. We've just blown off the rim. Now we've cut it up to stick it under the microscope. You can take a look. So that is the bead made of Kevlar. You see all the sort of woven parts to it. And then moving up to that apex protection, that's on the sidewall for impact resistance and cut resistance as well. Now on to the tread, so you see there's the compound, and underneath you have 4 layers of that carcass underneath the tyre tread. Obviously an important question is what happens to old tyres? Well, an important part of the business here at Schwalbe is the CSR, that stands for Corporate Social Responsibility. And in Germany, they send out these massive containers out to shops, so those shops can take in their customers' old tyres, and then they head off to a partner business called Pyrum Innovations that actually start the process of recycling these tyres. So shredding them into their parts, the steel, the fabric and the rubber. These bits, steel is sold off as scrap. Then the rubber goes into this process called pyrolysis. It's heated and put under pressure, and that splits into 3 different materials. You've got the gas, which is used to actually power the machine that does it. The oil that is then recycled, sold off to plastics or to be used in clothes. And then this recovered carbon black, that's the thing that makes your tyres black. So that is reused into making brand new tyres, and all this saves about 80% of the CO2 emissions. All right, well, it was fantastic to get a tour of this facility and see how big it is and learn a thing or two about how they design and make tyres. If you've got any questions about tyres, then leave them in the comments down below.